A perceptron is a simple machine learning algorithm used for classification. Here, the bank of authentication dataset is being used. This is used to load the dataset. This read underscore CSV, the file name is banknote authentication. Then this checks whether any values are missing. If a value is missing, it is replaced with the mean of that column. This is used to that the X contains the full input features and the Y contains the class which is the output. So this is standardized. This standardizes the data. It brings the different features to a similar scale, which helps during the training. So these are the output that's being generated. So variance, skewness, kurtosis, entropy, and the class. This is the null value that here it is on. If it is null, it is replaced with the mean of the column. So then the necessary pre-processing is done. Here, three learning rates are tested, that is 0, 0.0, 0, 0.1, and 0, 0.2. The model is trained with 50 epochs for each learning rate, initializing the weight. So, this is the initialization of weight. Initially, all weights are set to 0. This indicates that it is being set to 0. Four weights are needed for the four features, plus one weight for the bias. So, this calculates the weight sum of the four input features and added bias. This is the thing that actually calculates. So in simple, input into weight plus bias is equal to the output. So this is the formula. So this error equal to target minus output, error underscore sum plus equal to error into 2. The actual value is compared with the predicted value. The difference is called the error. The error is squared and added for all samples. So this is the updated weight. This is where the model learns. The weight are changed based on the error and the learning rate. So this indicates to find the epochs where the error is lowest. Then this indicates that it finds which rate gives the lowest error. So the output results learning rate with minimum error is equal to 0.2 and number of epochs with minimum error is 50 that is being used for training the data set. And then minimum error value MSE means mean squared error, that value is this. 0.2 was the best learning rate among the three tested values. This final underscore optimal underscore weight equal to saved underscore weight best underscore LRL. This gets the weight from the best learning rate. Then this indicates to display the bias, and this represents to display the weight for each features. The output contains bias, variance, skewness, kurtosis, and entropy. So the finally bias and four feature weights are being added. This tells what values the model learned for each features. So variance has this value, skewness has this value, kurtosis has this value, and entropy has this value. So here it creates a graph to show how the error changes during the training. So this draws a separate line for each learning rate. There are three lines, LR equal to 0.0 and LR equal to 0.1 and LR equal to 0.2. These are the three lines that are used to separate the learning rate. This shows the x-axis, that now the number of epochs, and this y label shows the mean squared error. And this marks the best epochs with a vertical dashed line. The graph here shows that the error for learning rate 0.1 and 0.2 decreases quickly and then becomes stable, while learning rate 0.2 remains almost constant. So the best result in this experiment is obtained with a learning rate of 0.2 at epoch 50 with a minimum MSE of approximately 0.0 061.